Okay, so in this video we're going to talk about a summary of exponents, their rules and definitions. I'm just going to do a really quick summary. There's 10 rules and definitions that I have to go over, and I want to do it in just about 5 minutes. So it's going to go very quick. A review of basic exponent rules of anything raised to the 0 power is always going to be 1. That variable is any real number, but it cannot be 0. This is because the exponent tells you how many times you're going to write that number. We're not writing that number any times, but there's always a 1 times something in math, period. There's always something there. Alright, any real number, including 0, raised to the 1 power. The 1 tells you how many times you're going to write that real number, so it's just itself. And then any real number b raised to the n power. We just write that n times. Okay, so that's a review of the beginning part of math. And now we're going to go into a lot more of how to manipulate these variables and exponents. So, you're going to see something new of b raised to the negative n power. Anytime you have something raised to the negative n power, you want to manipulate it and do something else with it. So the first thing we do is we take whatever's raised to that negative n power, we write the reciprocal of it. Then it becomes raised to the n power. We're doing the opposite of, and whenever the opposite of, we either have an opposite sign, a negative sign appear or disappear. So we're doing the opposite of so that we can make it a positive n. So anytime you see a negative exponent, you want to rewrite it so you can have a positive. So for example, say you get 2/3 raised to the negative 2 power. First thing we need to do is we need to rewrite what's inside the parentheses as a reciprocal. So we get 3/2, because when we write a reciprocal, we flip it upside down. Now that we've done that, our exponent becomes positive. Then we can actually finish solving this. Whenever we have something inside of parentheses raised to an exponent, that exponent's distributed to everything inside. So don't just put it on the numerator. You have to distribute it to the numerator and the denominator. So you end up with 3 squared over 2 squared. Gives us 9/4. So that's how you work with negative exponents. Okay. Product rule. Product rule is when you have any variable or any real number, which would be x, represents any real number, but it can't be 0, raised to a power of m, times any real number raised to the power of n. If we want to combine these, the basic rule is that we write our variable, or our any real number, and we add our exponents. Okay? So, when we're multiplying real numbers that have exponents in them, we combine our real numbers, add the exponents together. So if we have, say, x cubed times x to the 5th power, we rewrite our variable x, we add our 2 exponents, that gives us x to the 8th power. If you want to double check it just to make sure you're right, you can rewrite it in standard notation. X cubed is really x times x times x, because our exponent tells us how many times we write that variable. We multiply that times x, times x, times x, times x, however many times, 5 times. And then if we want to rewrite it in exponential notation, which means a condensed version, we know that x is the repeating variable here, and then we count how many times it repeats, and that becomes our exponent. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we know that it's right because we checked it. That is the product rule of exponents. Alright, power to power rule. This is when you have any real number that has an exponent raised to another exponent. So say we have x, which is any real number that's not 0, raised to the n power, and we raise it to the n power. The formula for this is just x raised to the m times n. So when an exponent's raised to another exponent, you multiply the exponents together. So say we have x to the negative 2 power raised to the 5th power. So the first thing we say is, oh great, I have a negative here. But let's first follow this rule. So we say x raised to the negative 2 times 5. That gives us x to the negative 10 power. And then we need to do one more thing. Whenever we have a negative exponent, we need to apply the rule of b to the negative n equals 1 over b to the power of n. Okay, so we need to write the reciprocal of x, which is 1 over x, all raised to the 10th power. Okay? That is the power to power rule. Now we're going to do the power to product rule, or product to power rule. So we have a product, say x times y raised to the n power. This is just like when we have anything else. What if we have parentheses that has an exponent on? We just distribute that exponent to everything inside. So it becomes x to the n power times y to the n power. That one's pretty basic. All right, now for quotients, division. The quotient rule is the opposite of the product rule. So we get x to the n power over x to the n power. Remember, x has to be any real number not equaling 0. Then all we have to do is say x, because that's our common variable, and m minus n. Okay? So let's do an example. We have, well, let's keep x, just to keep it simple. X to the 4th power over x to the 2nd power. So we want to rewrite that. So we say x to the 4 minus 2. That gives us x squared. So that's how you would combine this. You can also look at it as I have 4 x's in top. Kind of like when you do factoring of numbers. So if you factor your numbers out, and then you cancel out whatever's the same on the top as it is in the bottom. Well, I have 2 x's in the top, and I definitely have 2 x's in the bottom that I can cancel out together. And all I'm left with is 2 x's in the top. Okay, so whichever way really works for you. All right, and the quotient to power rule. So it's basically when you have a fraction raised to an exponent. All you're going to do is just distribute it to everything inside. So it becomes x to the n power over y to the n power. All right, then there is, the last one is a sign change rule. So that is x to the negative n power over y to the negative n power. All right, now x and y are natural numbers. M and n are natural numbers. X and y are any real numbers that don't equal 0. Anytime we have a negative, right, we rewrite it as a reciprocal. So what this does is if we write this one in the numerator, our denominator in the numerator, our old numerator in the denominator, both our exponents become positive then. And this is why. So let's just look at x to the m, or x over 1 to the negative m, times 1 over y to the negative n. Yes. Okay. So whenever we have negative exponents, we need to use the reciprocal and flip them. So x over 1 to the negative m becomes 1 over x to the n power. We could even put it here. Okay. Doesn't matter where. It's the same. Times 1 over y becomes y over 1 to the n power. If we were to multiply these together, 1 to the n power over x to the n power times y to the n power over 1 to the n power. Any number 1 raised to any power is always 1. So really you're getting 1 times y to the n over x m times 1. So you just get back this. That's your proof for that. Okay, so that's a summary of the exponents and rules and definitions for section 5.1.